So far, we have talked about two ways of solving these problems. Now, let's talk about solution number 3. This is kind of similar to what we had in solution 1, but let me first remove everything here. But instead of building a frequency table or array of booleans to store the to toggle the boolean value in each position, we're going to be using what we call integer bit vector. So instead of having a boolean array, we're going to have basically an integer of 0 that has about 26 positions, and so each position will be representing one letter, right? So so first we're going to need 26. So that's 5, 5, 5, 5, 5. And one more. So that's 26. So what we're going to do is whenever we encounter a letter, for example, a letter C, right? So a letter C is 2 letters away from letter A. So letter C minus letter A is 2. So previously in the first solution, we're going to be basically toggling the position 2 Boolean value from a false to true. So here we're going to be basically toggling the second position here in the bit vector from a 0 to 1. And by toggling, I mean if it appeared twice, right? So let me first toggle the second position to be 1. Right. So, and if it is the second time I'm encountering the same character C, I'm still going to toggle this. So if it's already a 1, so this time it's going to be a 0. So this is going to be switching between 1 and 0 all the time. So, but think about it now. If we have an even number of letter C's, so at the end this is always going to be 0. Right? So with that being said, at the end, if we want to have no more than one odd number of letters, we only have to check the final result in the bit vector that we have one. We cannot have more than one ones in this bit vector, right? So let's see, how do we implement that? All right, so first of all, let's talk about how do we toggle a vector, right? So a bit vector. So let's call this function integer toggle, and this is going to take an input bit vector, which is going to be integer. Just going to call it a input, and I'm going to pass in a index argument, and this index will be the position number which we have to toggle, right? So and so just think about it. How do we toggle this? First, we're going to be needing what we call a mask. What this mask is going to do is it's going to create a new bit vector, and this vector at the position index is going to hold a value of 1, and the rest of the values are all zeros. So in order to achieve that, we're going to use a bit operator in Java that's called a left shift. So and so we're going to be basically shifting the number 1 indexed number of times to the left. So what that means is, say I'm gonna start with the number 1, right? So that's my target. So say if I have 1, and that's the integer 1, and if the index is equal to, for example, 3, so I'm gonna be shifting the 1 3 times to the left. So 1, 2, and 3. So it's gonna reach this point. Right, that's what it means. And just think about it. If we already have an integer of all zeros, how do we toggle this bit here, right? So if there's the bit operator called XOR, or in Java is this operator. So if we do XOR, what XOR means is that if the two bits are different, it's going to be 1, and if the two bits are the same, it's going to return 0. So 1 XOR 1 is equal to 0, but 0 XOR 1 is equal to 1, but 0 XOR 0 because they're the same is still going to be 0. So it returns 1 only if the two bits are different. So, and this way we can use this logic to toggle this one right here. So basically, we shift this number of times to the left, and then we're gonna do a XOR. So input is equal to input XOR mask, and this notation can be simplified as input XOR equals mask. So essentially they're the same thing. So just gonna do the simplified version, and we're gonna return the input. So this way we take in the input integer, and we can toggle the position index of the input vector. Okay. All right. So we have the toggle function ready for us. So the next thing we're gonna have to do is creating the bit vector. So let's just call this create bit vector. Okay. So this is going to take the input of string. Okay, so this is where the real logic lies in. So we're gonna have to do a for loop. We're gonna loop through each character in the string input. So 2-character array. Okay, so and for each character, we're gonna be first of all calculating the index is equal to C minus A. Okay, so here we have the index of this. It's kind of similar to the index of the Boolean table that we use in solution number 1. So, and next what we're gonna do is we're gonna be toggling the bit value in at position index. So first of all, we have to declare the bit vector, which is going to be all zeros. So we're gonna say bit vector is equal to toggle. We pass in the bit vector itself and index. Okay. After we toggling this, and we're gonna be looping through each and every one of those, and finally we're gonna return the bit vector. So at this point, we expect if it's a permutation of a palindrome, this bit vector integer has no more than one number 1. Okay, so it has no more than 1 once. So we're gonna write our main function here is palindrome string input, and we're gonna first get the bit vector from this input. So it's going to be integer bit vector is equal to create bit vector, and takes in input as an argument. Okay, and then we're gonna check if this vector has no more than 1 once. How do we do that? Let's think about this for a moment. Say if I have a bit vector of 0, 0, 0, 0, 1, 0, 0. Think about this example, okay? I have only 1, 1 in this bit vector. And if I were to subtract 1 from this one here, what would I get? I'm going to be getting 0, 0, 0, 0 because I'm subtracting 1. This is a binary operation, so 0, 1, 1, right? And this time, if I'm going to do a AND operation on these two, what am I getting? I'm going to be getting all zeros, right? So that's a trick that we can use. So subtract 1 from the bit vector and do an AND operation, and we should be getting a 0 if there's no more than one ones in the bit vector. So let's do that. So the boolean, I'm gonna just say return bit vector and bit vector -1. So let's copy and paste this into IDE and see if it's working. So I'm going to be using IntelliJ again. First off, let's remove everything here. Okay. Oh, sorry, it's equal to. Oh, sorry. Need to put one more parenthesis here. Okay, there we go. All right, so let's make everything static so that we can call it directly. Static. And static. So, all right, let's go ahead and run this. Again, we're getting true, true, and false. So let's talk about the time complexity again of this algorithm. Again, we have to do a for loop to loop through each one of them in order to toggle the bit value at that position. So again, the time complexity will be a big O of n.